All right, well, thanks everyone for giving me the opportunity to discuss a project that we recently completed here at TTI. As Kathy mentioned, I'm kind of in the branch or the side of TTI that focuses on roadside safety. Again, there's a lot of different aspects of what we try and do here, and ours is kind of in the realm of, if you happen to depart or exit the roadway for various means, having kind of a line of defense with guardrails, barriers, other things that we hope to design to be crash worthy and safe in the event. And those are, again, typically there to protect motorists from hazards, other things that might be on the side of the road. So, in that history, we've spent, 50 plus years designing roadside barriers for, standard vehicles, passenger vehicle, pickup trucks, heavy vehicles. And though we've obviously known that motorcycles are users of the road, we've never really spent any time or devoted any research or effort to think about how these systems that are designed, guardrails and barriers, and how when a motorcyclist were to potentially crash with one of these, how they would interact. We obviously know that there's a lot of aspects to those that would not be safe for a motorcycle rider. But again, I think about 10 years ago, we started asking the question, can we do something about motorcycle riders? We continue to see certainly a high number of fatalities when we look at the crash data, road users impacting, again, guardrails and barriers. And so, again, we kind of started to ask the question of what we can do. And so this was a project that as one has come about. It's basically through a transportation pool fund that consists of about 7 states, Texas being one of them, and a few others, Utah, Illinois, Georgia, Louisiana, to name a few. And so this was kind of a dedicated project, again, to look at specifically from the motorcycle side. Could we design and develop a barrier system that might improve safety from what's kind of the standard systems that are on the roadside? So I'll just, as far as what I'm going to do here, just go a little background, discuss the design, what we did to kind of develop and optimize the design. And then, we want to, of course, test and prove out our designs. And we do that through full scale crash testing here at our Proving Ground lab at Rellis campus. So again, this one was a little bit specific, but also we tried to kind of create a design that would work in multiple situations. But, typical roadside system is a concrete barrier that you'll see in lots of different avenues or applications. The one you see here in this specific picture was kind of a specific instance where some states were encountering some high volume of fatalities with motorcycle riders. And then, in tunnel system, you're going to have, likely some kind of barrier on the side. And you might need to allow access to workers who are maybe walking on top of that barrier. So you might have not only your concrete barrier that you could interact with as a vehicle or a motorcycle user, but you might have some kind of railing on top of that concrete barrier. That railing could be there, again, particularly for pedestrian or worker use. So for kind of their usability. And so when you kind of have this multi-user kind of setup, and again, it's not specific to just tunnels, you could have this on certain walkways or certain passovers. So it's not specific to this. That can obviously change the dynamics of a crash. And so we think specifically about a motorcycle user, not being protected like a vehicle. If you were to have that interaction, particularly with that pedestrian railing, you can only imagine some of the ways that could, be a negative outcome and result in fatality. And so, again, there have been specific instances where that was occurring. And so, as part of this project, we want to see, can we design something that might be a little safer, and again, kind of improve safety, reduce the probability of severe injury, for motorcyclists. But we also want to make sure when we went this route, we didn't, negatively affect how it would perform for a vehicle impact. So we kind of had a dual safety approach, dual design objective. Can we design something that would be safe for motorcycle riders and also for standard vehicles at the same time? So again, we kind of looked at this from 2 approaches. One, trying to design and optimize basically a railing that we would put on top of the concrete barrier for motorcycle impacts. One of the challenges we encounter is, again, that this is something we're kind of doing where there's no standards, there's no requirements that anything on the side of the road or a roadside barrier be tested for motorcycle impact. This is something we've been trying to do to push the envelope a little bit. And so there's no guidance to tell us on, when you design and test something, here's how you determine that it's, acceptable. Here's what speeds to, hit the system at. We know probably you're going to be coming in at an angle off the, if you're departing the roadway lane. How do you, again, determine if it's improving safety? Is that looking at injury values for a potential rider? There's certain criteria we want to have. So we kind of had to develop some of those criteria along the way. For our standard vehicles, that's much more well defined. We have a kind of standard guide that prescribes, what speed to hit, what type of vehicle to use. And again, for kind of standard vehicles, that's going to involve a small car and a pickup truck. And those are usually at a higher speed, 62 miles per hour and 25 degrees. So we kind of knew a lot of those parameters going in, and that was, certainly kind of helps. But again, along the way, we kind of learned some things with the motorcycle. So I'll just get into, a little bit of what we started to think through and brainstorm. We knew we didn't want to leave these big openings. You could think about a rider leaning into the system. You wouldn't want maybe an arm or anything kind of wrapping around a discrete post. And so we wanted to have kind of more of what we would call maybe a continuous system, kind of more continuous style of protection rather than having something that's maybe more exposed and singular and discrete. And so I'm not going to get into, a lot of the information necessarily about each of the designs, but this one kind of generally involved more kind of like a plating system, just some horizontal plates that we can install attached to the posts. And again, kind of have that continuous. You could have different materials for that plating, kind of dependent on what kind of aesthetic you needed or wanted for that application. The second one was a chain link fence. So some kind of fence system, again, using kind of a standard chain link material. And, if you kind of maybe design a certain way, you could, again, kind of have more of that continuous protection. And it's going to be maybe more readily available in a type of system that they're used to installing and using, maybe in other applications that they could use here. And then the other one we looked at is kind of a variation of that design too, and that's just really providing some offset, because we know with the chain link fence, you're probably gonna, if you're leaning into it, interacting with it, whether it's a vehicle or maybe a motorcycle rider, it's gonna likely deflect a little bit. And so maybe having some offset from the vertical posts might provide some advantage and some, just kind of improved design or crash-worthy performance. And so we kind of reviewed these three design options with the states, discuss, a lot of the, advantages, pros and cons, discuss cost and how these could be installed. Ultimately, we kind of finalized that process and decided on designing the essentially design two, which was having the concrete barrier with the chain link fence mounted directly on top without an offset. And so that was kind of a starting point for us, but we knew we probably still needed to kind of figure out, various aspects of the design, what size of the mesh, you can have a 1 inch, kind of a square mesh for the chain link fence. You can go up to 2.5. What would be kind of the better design parameter there? Do we need additional kind of horizontal posts? Where do we want to kind of space a vertical post? So there are a lot of design aspects that we wanted to figure out, decide how they would affect the outcome before running, full scale crash tests. And fortunately, we're able to simulate a lot of these impacts in a simulation environment. And that just allows us, again, to kind of optimize the design and see where we might have some issues before we get to crash test day, and hopefully resolve them and come up with a design that we think will work well. So basically, it's kind of a 3D model environment, so we can build a full scale model of the barrier. We also have reverse engineered and taken apart a motorcycle and scanned it to have kind of a realistic motorcycle model. We have a instrumented dummy, also computer model as well. So we can kind of pair all those things together and, again, try and replicate the environment that we would see in a full scale crash test to the extent possible. This was kind of our starting point, and again, kind of more of a base system where we had just vertical posts and one horizontal railing that went along the top. And then you kind of had a standard 2 inch by 2 inch mesh size for the chain link fence. We're using kind of a standard barrier height, which is 32 inches, which is, again, common for most roadways in most states. And then we wanted to have, we were also, again, trying to work with this being a pedestrian railing. So there are certain requirements we had to meet from an ADA and a kind of pedestrian usability. And so there were some requirements there that we were also balancing. So that's where you get kind of that prescribed 42-inch height to get to that top railing. So this was kind of our first go at it. And you can see here, not really the outcome we generally wanted. But, again, we kind of knew this would be a starting point, and I'll show it kind of from a different view here. But really what we maybe kind of expected to see in some senses, without really a lot of stiffness in that chain link fence, it deflects a lot, really allowing that kind of motorcycle rider to lean into it. And then a lot of interaction with that vertical post, and even, with there really being nothing holding that chain link fence on the bottom, that hand and arm kind of goes underneath and down. And so, of course, that would be, a very severe, fatal, potentially interaction. And so this, as a starting point, we kind of, observed that certainly we need to resolve some of this, and we wanted to have something that particularly didn't allow any kind of component or element of the this instrument and dummy model to get really on the, I guess you could say, the backside of the chain link fence. We know that that's not really going to be a desired outcome. So we went through a few iterations. We started with trying to resolve that issue along the bottom by adding another railing where you could have that chain link fence tied, and it provides a little bit more rigidity along the bottom. And then even with that approach, we were still seeing some of that shoulder and head really deflect the kind of middle part of the chain link fence. And so that's where we went to a second iteration that we called, kind of the head rail. Really, that just meant it was kind of a horizontal railing that was more or less kind of in line or in the location of where the head was impacting the chain link fence. And then we added, again, a shoulder rail, or looked kind of at another horizontal railing that was kind of more where the shoulder, the instrumented dummy was. And then we ended up kind of combining both because we felt like we really needed both to have a more uniform and continuous interaction and less deflection of the chain link fence to prevent some of that interaction near that vertical post. And so this is kind of our first look at this one. And again, we were looking at different speeds and angles, just trying to see kind of where the design, how it would perform in kind of various ways with various speeds and angles. So this one's at 35 and 15. I can see here a little bit from this angle. But again, with that kind of horizontal railing, obviously you're still kind of contacting it with the helmet and some of the shoulder, but it's not really deflecting as much of the chain link fence and pushing the arm and shoulder into that vertical post, which is what we were trying to avoid. A few other scenarios here where we just looked at higher angles or higher speeds, again, just to see, at some of these other combinations where we see other types of interactions. This one's at a little bit higher, and so you can see quite a bit of a harder hit from the shoulder and head at 45 and 25. So again, we saw, compared to what we were seeing previously, less interaction. That arm kind of just gets trapped a little bit rather than kind of go under and through and kind of wrap around that vertical post. And kind of same thing with the shoulder and head. It certainly is kind of pushing a little bit, but it's less of pushing and kind of hitting that vertical post directly, kind of with that, what would be kind of a blunt object there. So one thing we were able to do and kind of output from the simulations is that, in that kind of instrumented dummy model, we were able to see, accelerations at various body regions. So maybe there's, we can have an accelerometer in the head, a load cell. And so what that allows us to do is get, theoretical accelerations, forces, maybe in the neck, maybe in the chest, acceleration from the chest. And there's some data out there to suggest, when you reach certain thresholds, you start to have a higher likelihood or a higher chance of a severe injury. And so you can see in that very right column some of those limits, which again have kind of been developed over the years by doing various types of kind of testing to establish what those limits are. And what you'll see is that, for the most part, and really where there's variance in the cases, it's all the same design, just varying the speed and angle. We really started to see that, kind of the main takeaway was that when we went to that 45 and 25, that's where we saw multiple injury criteria start to exceed that threshold that we were aiming to keep the values under. And so that was kind of where we're, when we're trying to decide what speed and angle, that we leaned kind of more towards the 45 and 15 in terms of what we thought would be feasible to achieve, at least with this specific design. Yes.
What does some of that mean? The HIC?
Yeah, so the HIC, that one is specific to the head, and that really just takes a resultant acceleration. So you take your XYZ acceleration that a theoretical, motorcycle rider would experience. You convert it into this criterion called the HIC, and again, it's really just kind of resultant, just overall, what does the head experience in terms of accelerations? And then those next three are really just all about the neck. Can you have what type of basically X or shear force are you having? That Z force is really going to be, your axial tension and compression in the neck. And then that neck moment is, just how much is it bending and how quickly. And so those are the three main parameters we see with this. Obviously, with this type of impact with the concrete barrier, you're going to have a significant amount of load or, impact with the leg. So, we can look at the femur force, just in general, didn't show it here on this table. Certainly there are some things that we're limited in what we can measure with the instrumented dummy that I think certainly could be an area of improvement. specifically if we're trying to look at motorcycle impacts and crashes. But these are ones that are kind of used in more standard vehicle testing, like NCAP, when they're, trying to test seat belts and things like that.
Yeah.
So of course, we want to make sure that some of these design elements that we incorporated wouldn't negatively affect the outcome of a impact from a pickup truck. So again, we know generally that we've tested many of these concrete barriers that don't have any, maybe chain link fence attachment on top. We know that they work well for pickup trucks and small car vehicles, but we want to make sure with this new system, would it have any kind of negative outcome? And this is kind of a pretty standard behavior. Again, you're going to have that kind of front quarter panel want to, engage some of the chain link fence. But nowadays, vehicles are designed such that many of those elements just kind of tear right off without really putting a lot of damage into the rest of the vehicle. And so it's usually nothing significantly harmful. Typically, what we're looking at with these vehicles or these tests is we want the vehicle to be stable throughout the event, so not roll over. And we have a way to also kind of measure theoretical, again, mostly acceleration as to what an occupant would experience. And we kind of have threshold values for where, again, we would see if you were to cross those thresholds, where you would start to see a higher chance of severe injury. And again, just here from an overhead view, and you can see again, some of those quarter panel elements, the headlight, all those are kind of engaging around that vertical post. But again, it really just kind of results in tearing off components and doesn't really do any damage or other things to the rest of the vehicle. So again, here we have limits on, those first two, the OIV, and then the next two, ORA. Those are really just acceleration-based values where, again, we're measuring acceleration in the vehicle, and we're trying to kind of equate that to what a theoretical occupant would experience. When you experience those accelerations, we want to be under a certain threshold, which are in that kind of far right column, the MASH limit. And you can see here, we're generally kind of well within those limits. And again, typically what we would expect, and nothing much different than what we see in a standard concrete barrier test. So kind of main takeaway is that we didn't really see any negative outcome or negative effect of having that chain link fence on top of the concrete barrier. So, just to kind of summarize a little bit here, we had that kind of original system with the vertical posts, maybe just a single horizontal rail. And we had kind of that, again, severe kind of snagging and head contact with the vertical post. We went through those iterations and really tried to find something that reduced that. And we had to add those additional horizontal rails. And again, we looked at, varying levels of impact conditions. It seemed about when we hit that 45-25 combination, that's when we started to see that, much higher level of injury criteria and an outcome for the interaction with the motorcycle and the chain link fence system. One thing is a limitation really of our approach and what we were doing initially is that, we have a single motorcycle and we have a single rider that we're simulating in this environment. We know in reality, of course, that there are multiple types of motorcycles out there. They vary in their, design, their kind of aspects of seat height, handlebars, where the handlebars, things like that. And we know with this particular system, if you were to start to change what motorcycle you were coming in on, that could have an effect on how the design were to perform, and particularly where we had those middle horizontal rails. And as we were looking to this, we tried to get an idea of what's the range, particularly of seat height. So if you kind of change where that rider is sitting, that's going to basically have an effect of what height they're at as they start to come into the vehicle. But there are other aspects of that, of course. It also depends, that's kind of in combination with the overall posture and height of your rider. But we know, at least specifically on the motorcycle side, we can kind of see and know some of these values. We may not know specifically in the motorcycle population, what percentage of riders kind of go across, various spectrums of kind of, again, their height and weight and things like that. So, we try to look at it, in terms of, you might have like a cruiser or touring type bike, which might be a little bit lower. You could have maybe a standard or a very specific sport type motorcycle that might raise the overall seat height. And so you can see there's kind of a few ranges there. But what we tried to do is essentially establish, lowering the seat height to look at a lower range with the model, and also looking at the higher side. And so we started here on this lower seat height, where again, we tried to just kind of bring it down a little bit. And what you'll see is that with that, that shoulder kind of goes a little bit under that rail. And so that's kind of what we were originally concerned about, is that, have we designed these middle rails to be a little bit too specific to the rider and motorcycle combo? And so when we started to investigate this, as we kind of expected, we were starting to see some additional issues kind of come up. And you can see, maybe it's not the most problematic, but we kind of wanted that shoulder rail, that kind of lower middle horizontal rail, to provide a little bit kind of more of a capturing of that shoulder. And it seemed like with this lower seat height, and also thinking, that you could also have a shorter rider, we thought we probably need to maybe modify this slightly to be able to kind of address this. And so we essentially kind of space those out a little bit more, instead of it being basically that those are 15 and 7, or going from 17 inches kind of from the top of the concrete barrier. We brought it down a couple inches to 15. Again, we didn't want to maybe make that too far of a gap, because then you could maybe have the top part of the shoulder or the head kind of go and wedge into between those horizontal rails. So, we tried to kind of find a good balance there. And so we ran, that simulation essentially again, and you can see a little bit less opportunity for that shoulder, and it kind of more engages directly on the horizontal rail, which is kind of what we were intending. And so you can kind of see it there in kind of a screenshot capture. This is kind of going back, with our standard seat height. Again, we kind of, as expected, worked where it just engaged that shoulder and kept everything from more or less directly engaging with the vertical post. And then we went with a little bit of a higher setup. I don't have it necessarily from a rear view, but you can see there, again, with this one, it's making sure the head maybe doesn't go up and over kind of that upper horizontal rail, and we essentially were able to see that didn't happen. So when we kind of thought about trying to think about the various seat heights and how riders will differ, we did kind of make that minor adjustment just to make it to be where it would be a design that would be, again, crash worthy for a wide range of motorcycle riders. And then again, with that kind of minor update, we went back and ran the small car and pickup truck. You can see here with the small car, and what I'll kind of mention is we didn't run a full-scale crash test with this, and that's really because we didn't see any interaction with the small car and the chain link fence. You can see it kind of leans a little bit, but it doesn't really engage with anything. And since we know that these concrete barriers have already themselves, without the chain link fence attached on top and tested and shown to be crash worthy for cars, we didn't necessarily see need that it would just be more or less a retest. And then again, on the pickup truck, pretty similar behavior to what we're seeing, even with that modified rail height. And so we felt pretty confident moving forward. Really no big changes in what the occupant risk data, and I didn't show it here, but also the injury criteria for the motorcycle rider. We didn't see any big changes when we made that small adjustment to the, I guess, that lower horizontal rail in the middle section. So this takes us into the full-scale crash testing. So again, where we kind of landed on was having this upright motorcycle crash test and conducting it at 45 miles per hour at 15 degrees. Now, in that model environment, we had instrumented dummy. We also happen to have with our proving grounds, fully instrumented hybrid 3 50th percentile dummy. It can, again, do the same thing where it can measure accelerations. It's got accelerometers in the head, the neck, chest, legs, and in addition, load cells in certain regions. And so we can look at some of those injury criteria in the full-scale crash test environment. Again, we don't really have a lot of data or any kind of prescribed, here's what type of motorcycle to use. We've kind of leaned on using more of a sports style motorcycle, like a Kawasaki Ninja, and with the general thought that that might be a little bit more tendency, maybe with the seat position and the rider posture, to maybe have a little bit more lean and kind of forward ejection, which, kind of our thing has been that it might be a little bit more critical in the event of a crash test. And then if you were to kind of, again, have an impact with other types of motorcycles, the idea is that it would be a little bit less severe of an impact. And then again, we wanted to look at how the vehicle crash test would perform with the pickup truck. Again, we didn't run the small car, but with the pickup truck, it's kind of our standard 62 miles per hour and 25-degree type of impact. So how we set this up, again, we have our proving ground facility. We're able to build and construct kind of a full installation. So we can take what that design was from the model environment, and we can, build a concrete barrier, and you can see the chain link fence attached on top. So you can see there, you kind of got kind of little panels where you have 2 posts there, and you have a single vertical post in the middle. You have those 4 horizontal railings, one on top, one on bottom, and the 2 kind of in the middle with that little bit of spacing. And then we're able to kind of, again, bring our vehicles up to speed and crash them into the barrier. So again, with the 2, we had the motorcycle vehicle. So you can see there we have our Kawasaki Ninja motorcycle. The way we're able to do it is we have our kind of a tow truck pull it up to speed. It's on these kind of guide cables, so that's where you see some of those extra wheels on the back. Those are intended to just kind of keep it stable, and then those actually come off and release, maybe 15, 20 feet before impact, so that it's completely freewheeling. And then, kind of standard setup with our pickup truck where it's doing something similar. We don't necessarily need kind of the additional wheels, but we also pull it up to speed with a tow truck. And then again, you can see there we have our instrumented dummy where it's in kind of a seated position. We tried to kind of put, a standard or just a general leather jacket and leather pants, and of course have kind of a fairly standard US DOT approved helmet on top. And then we also put gloves and boots on as well. And, partially we know that not every rider would be wearing that, but we know part of it is kind of a cost perspective for a lab that we don't want to put. These dummies are extremely expensive, and so if we can, kind of protect the skin to some degree, or at least provide some level of protection, and we're also using something that some riders may be wearing, it kind of helps us in the long term protect some of these items, such as the instrumented dummy, which they're not typically used in this type of environment where they're as exposed as they are, where we're basically throwing it from a motorcycle into a barrier, and so we have to kind of proceed with some caution from that perspective. And then again, in the standard pickup truck, again, we're bringing it up to speed and impacting at that 62 and 25. So I'll start here with just kind of a general video of what occurred in the motorcycle impact. So again, we're coming in at a 15-degree angle relative to the barrier, and that's at a 45-mile-per-hour speed. We'll show this one more time, and I've got some slow-mo videos. So you can kind of see that release of those wheels in the back just before it hits. Motorcycle impacts, and then kind of falls to the side here just in front of the barrier. So I got kind of two slow-mo videos kind of getting some different views. You'll see particularly on the right video that's kind of from the rear side. It gives you kind of a good indication of what that interaction was, where again, that arm kind of gets trapped a little bit there, but we don't really see it necessarily catch too severely. Obviously, you probably have some kind of fingers from the hand kind of engage a little bit, but doesn't necessarily stay for too long. The helmet and kind of the head part of the instrumented dummy, certainly does engage those rails, but it's kind of more of a contact and rebound rather than kind of leaning in and hitting directly on that vertical post. So from that perspective, particularly with what we had seen in the original design, we kind of saw what we were hoping to see in the outcome of the crash test. But of course, you still have some of that interaction. And then what you kind of see there is that the dummy actually stays with the motorcycle through most of the event, falls to the ground, and then kind of slides out, which is, pretty typical what we see in some of the few crash tests that we run. Sometimes we'll see, the rider kind of completely disengaged from the motorcycle. Kind of just depends on what we're impacting and what's happening. But I'll let this kind of show one more time here on this rear side, particularly. Obviously, again, you're going to have that interaction with the leg and probably a fair amount of load and, likely injury to that leg. And so that's where we can look at that, and also the chest and the neck and the head as well. So what we saw particularly, again, with the focus on what we're seeing, originally with some of the high injury values on the head and neck to what we saw in the crash test. What we ended up kind of finding is that, the degree of injury and the measure of acceleration, that Hick value, again, looking at the acceleration of the head, was at a 348 value in the crash test, which was well below our 1,000 limit. We saw the forces in the neck, again, be at, again, at a level that we would say that there's a low likelihood of severe injury. And that, applies for both an X, kind of a forward shear load or a compression and tension load in the Z direction. And also kind of a lateral bending moment about the neck as well, all those kind of being within the limits. And then we wanted to look at, again, and see from the pickup crash test how this would perform as well. And, kind of more or less, at least as you see it, kind of happening pretty quickly here, looked like it occurred pretty similar to what we anticipated from the simulation environment. Again, vehicle stayed stable throughout, didn't roll over, which is what we're looking at. I'll just kind of show it one more time, particularly with the slow speed video on the right. Again, as expected, you have components of the quarter panel and the headlight engaging with the chain link fence, a little bit of the door and the mirror, but nothing that kind of led to any necessarily undesired kind of specific outcomes. And it's something that's typically, certainly allowable within our crash test criteria. So yeah, I mean, just to kind of wrap up, but kind of a quick wrap up on this slide, but I'll kind of add some other items as well, is that, again, we kind of came at this trying to see if we could design something that would be mountable on top of a concrete barrier that would at least indicate some level of acceptable or improved performance from what we know could be if there were kind of the standard designs used in the installation in the field. And so, kind of with that system that we modified and added additional horizontal railings and went through that design optimization, what we really saw in that full scale crash test was, kind of the desired outcome of particularly not having any limbs or components of the ATD, kind of snag or really catch on any kind of vertical or other types of discrete elements. So we're able to kind of see that at least improve performance. When we what we do after that crash test is we, of course, take the dummy inside, we take off the jack and the pants and see, is there any structural damage? Is there any damage to joints? Kind of the skin of the ATD to see if there would be any potential lacerations. What we really saw is that there was no damage really across any part of the ATD, whether that was the skin or any structural components. So, we're able to completely, continue to reuse it and everything was working properly even after the crash test. And then again, we had these kind of injury limits, which, we're still kind of learning more about, but at least from what's kind of typically used in a safety environment, whether that's maybe more like vehicle seatbelt testing, we at least saw some, head acceleration and neck forces be within some of these prescribed limits. Certainly I think there could be more thought or research into actually looking at motorcycle crashes in the field and trying to understand some of those injuries and how they start to occur. But at least, I think a good starting point for us to establish some baseline of performance. And then as we saw with the pickup truck crash test, that attachment or that system didn't have any negative influence. And we saw a pretty standard outcome and satisfactory performance with our pickup truck MASH crash test. And so, in that outcome, we'd be able to say that, this system kind of seemed to work or indicate some level of improved safety performance for both motorcycle riders and, also standard vehicles, pickup trucks and small cars. And so, as we kind of had completed this project, which was completed about a year ago, we're basically working with the states and, they're starting to maybe identify areas as they're maybe putting in new installations or if they want to go in and maybe change certain areas, maybe again, where they've identified a higher number of motorcycle impacts with barriers. This can be a system that they might be able to at least begin to implement. And then I think, again, we're kind of in a place where this is very new to us in terms of trying to design systems and improve, this type of safety for motorcycle riders. I think a very valuable aspect of that is going to be how these actually do in the field. Or, states seeing reduced injuries or injury levels or even, number of impacts, things of that nature. So I think there's still a lot to learn kind of on the implementation side. How do states see it working? Is it working as intended? And we don't do that, we do that across the board. We've been doing that for years with our roadside safety systems, always trying to see how they're performing in the field. But as these are a little bit newer and we're trying to kind of specifically target a certain type of road user, I think some of that data will be very valuable, but, is still kind of yet to come. So that's an important follow-up. And then we're also working to establish more consistent or very specific criteria for how you run these tests, such that, other labs and as people start to maybe develop systems for this type of application, everybody can be on the same kind of playing field as far as how to run these tests, how to evaluate them. That's certainly kind of needed for a lab practicality or kind of how we run the tests. And also just helps, in terms of the environment for how these can be designed and optimized, that everybody's kind of working with the same parameters, kind of the starting point. But yeah, that's generally what I have. I'll happy take any questions or if there are any comments on this particular system. It's always interesting as we've made some of these presentations to maybe more motorcycle rider groups. Some of the feedback we get is always certainly valuable and quite interesting as we've kind of been going along on these projects.
Thank you, Nathan. Any questions in the chat or come off mute?
I'll give my 2 cents here real quick. Let me preface by saying I think it's an awesome idea. It's a good project. I think the idea does work. But if I was sitting on the board, having to approve the budget for this without, obviously, I don't know all the parameters to it. For me today, it would be a no-go. Um, I don't know where the application is that you would plan on installing this, on all the Texas highways, roadways, freeways. I don't know. Again, I don't know a lot of the info to it. But um, other than a bridge or an elevated surface or something of that sort, where there's the highway is separated or raised or whatever, in that situation, I think this would be an awesome product to put for that application. Um, the problem is less than 70. I don't know what the exact number is, but I'm just guessing. I'm just throwing out a number. 75% probably of our Texas highways have no concrete barriers. I don't know what the reason for that is. TxDOT's reason for that is, but I mean, when's the last time that you were on a freeway, and for any length of stretch other than in a metro area, that you saw concrete barriers completely stretched throughout the highway? Uh, we're talking about a big expense here, and that's probably a good time that to build this product, if we're going to be doing that. But it kind of goes along with a small percentage of motorcycles actually hit a wall during impact. 95+% of the time, it's either going to be a forward or a rear, impact area, and that's going to be the direction of travel that the motorcyclist is going to be going after an impact. This would be something like, for a slide, or maybe after the motorcyclist was hit and went in that direction, that's going to hit, a barrier or a wall or slide off the road or whatever it might be. But if even in that case, if the motorcyclist is already sliding on the ground, they're the netting or the fencing is not going to come into play. And if there's vehicles that are involved in the accident that we know slide off the road the majority of the time, that hit all these barriers in the metro areas or on the freeway or in construction zones or whatever it might be, they're going to be the ones that are going to be damaging the application probably 99.9% of the time. So if they have to go out and replace a concrete barrier, whether the fencing is damaged or not, it's going to take it out of play. And then we're dealing with that issue. So I just don't know. Like I said, I think it's an awesome idea. It's for specific purposes, but to have something like this for complete stretches on the highway, I just I don't see it being feasible.
Yeah, no, that's a great point, and I think you hit the nail on the head there. I think, generally, I think none of these states, again, it was, trying to think a little bit nationally as we were working with states beyond just Texas specific for this project is they're, yeah, they're probably not going to be going around and replacing maybe guardrail or maybe their current concrete barriers and installing long stretches of this fencing system on top. Kind of depends a little bit on the environment, but for a rider and with a barrier, if they don't need a railing system there in the first place, it's probably better if it's not there because you're still going to have a high amount of injury, and so maybe instead of if you're impacting with that barrier, if you do happen to kind of come in that very specific, uh, oblique, maybe upright or sliding, as you mentioned, which again, certainly is probably a more rare occurrence. Um, again, the idea is that I don't think a lot of states are going to go out there and start adding or kind of changing hardware. I think this is kind of to help with some specific situations that I guess, kind of from their perspective and from what they've been telling us have been occurring at a higher frequency than I guess, maybe was originally thought. And so it has kind of been a bit of a problem area for them. And again, that's happened even with upright or sliding style of impacts. And so I think it's happened just enough that they've wanted to have a system that could help in those specific situations. I'm not really sure why those have become problem areas or why some of these specific applications. I think that would require a little bit more nuanced understanding of how these are all installed. Maybe in a tunnel network, you're just on a tighter, lanes, you're on, maybe going through tight curves, visibility is maybe a little bit limited. In other areas, maybe it is also just, the nature of the roadway that's causing some of these higher frequency of crashes. But no, I completely agree. I don't think it would be ideal or practical for states to go around, replacing kind of their current hardware, at least in long stretches with this system. We have done some looking at what is used more commonly in Texas, the WB guardrail. We have looked at trying to kind of come up with a system that would be kind of with a similar approach, that it would be, maybe improved level of performance for motorcycle impact. So I think we're kind of trying to, again, as this is a new area in general for us, or at least a new approach of trying to design hardware for motorcycle riders. This was kind of one instance that I think, yes, I would probably agree, it's going to help maybe in a finite, limited number of applications. And then again, maybe in other ways we can improve other hardware that maybe is used more readily or more widely. And I think some of those efforts are still ongoing. So yeah, that's a great point though. And I think, we'll kind of see in some of those limited applications, what kind of benefit this could provide long term.
I think construction zones,
Mhm.
a lot of construction zones use these concrete barriers, and they have wrecks because people are, when you go through Waco, you'll see what I'm talking about. They're in there and they got what's supposed to be a 4-lane stretch of highway narrowed down to 2. You got an 18-wheeler on one side and you're right up against the concrete barrier on the other. The little road braille thing that you're supposed to keep you from moving over scares people.
Mhm.
And they freak out, so they move over. So, it's a real tight 2-lane road right there. And that concrete barrier is right there for that construction and that lane divergence that they're doing. In this application, it would keep the motorcyclists, from my opinion, and debris from a car crash
Mhm.
from flipping over into oncoming traffic on the opposite side. Limited purposes like he was talking about. Good construction zones, areas, bridges, inner city tunnels, things like that, probably great for it. But I agree with him on the actual roadways. I didn't see any concrete barriers coming down here from Waco. I mean, but downtown Waco, they're all over the place.
Right.
They're
But
moving every traffic lane and exits, and people are freaking out in the suicide squeeze and all of it because, they're trying to cram everybody in and then narrowing down, and it's nuts.
Mhm.
This would be a good application for situations like that, but.
yeah,
And if you could make it like Lego bricks, I guess you would say, where the fence is already on there and they just drop in the
Drop it
barriers
in.
with the fence already on. They don't have to stop traffic now
Mhm.
to add a fence, just
Right.
as they start going for these new applications. That would make it easy, but that's my opinion.
Yeah, no, I think work zones would be, especially depending on kind of the setup and how narrow they get and how much traffic volume is, could have some good application.
Well, it's crazy. They just spent all this money 4 years ago putting in widening I-35 and now they're
Yep.
tearing it all up.
doing it again.
And you're going, what happened to the taxpayer money that y'all
Yeah.
just poured all this? Why didn't y'all do it the first time?
Oh, because Waco grew way too fast.
Oh, no, I've been living there since 91. Come on. Fine.
I'll jump in with my, with something that Nathan knows far more about than I do, but just as a general, because I know for, the presentation Nathan did today, just to give some context to folks, his group with all the crash testing that they've done over 75 years now.
Pretty close, yeah.
It's really interesting to see all the different, they end up doing a bunch of very specific scenarios that each particular one, you'd say, well, you'd only see that in such and such a place. And they're like, yeah, we know. Here's the place and here's why we designed it. And so, yeah, the crash testing kind of, it's almost a stepwise problem solving solution, because they'll come up with something like, okay, a bunch of our roads have this type of barrier. All right, let's test crashes against this type of barrier. And then they'll say, okay, now we've got roadways, now we got a bridge with oh my gosh, you don't want anyone going over that. Okay, we need to add something to a barrier for places where you have this. And so it's interesting because each particular crash testing project that they do, I think, as far as I know, they all come from like highway engineers saying, hey, we got a thing we got to solve. here, we got this problem and we've got this sort of hazard and this kind of risk. Help us figure out a thing to keep this horrible thing from happening. And then so they go and do this. So yeah, no, it's a very good observation that something like this you wouldn't see it widespread. You'd see it in the places where this type of crash could cause a real problem for a certain type of road user. And so yeah, it's like they do these projects that are kind of piecemeal, but then I love the Lego analogy that got brought up, because yeah, it's like it does, like you end up with a roadway system where they're like, okay, fix this right here. Okay, fix this right here. And it.
Yeah, a truck hits this segment or these two segments of concrete, you just pick those up and then put two down with the already in play with the fence and everything, you know.
Yeah, I think our industry is very reactive, which has some pros and cons, but it is a lot of that, you know.
Maybe we should have motorcycle lanes like we got all these bike lanes.
Yes.
Yeah,
There you go.
That's actually been brought up.
it has.
I mean, I don't see anybody using these bike lanes where I'm at, but they've spent time and everything putting them in.
So a couple of things. One, about the specific, and you mentioned bridges, is Marcy is our crash guru, and that her one thing for motorcycle crashes is the ones that are rule going off the bridge and landing in a dry creek bed, and the fatalities, the serious injuries that go along with that. Which is why she'll never get on a motorcycle, but this is the type of application would be there, which right now I've been driving 306 out in the hill country where they have the Guadalupe River horseshoe, which you get your floaty, you start on one side of just right off the road and you float around and get back up on the road and you walk back and do it again. Out near Canyon Lake between Austin and San Antonio. I have been on that road for more decades than I care to admit. But I noticed this time as I was driving by, they had these really tall, they've got the Jersey barrier, the concrete barrier, and then they have the really tall fence, where the pedestrians are carrying their tubes. You get a gust of wind and that blows into your roadway. Now you have a roadway hazard. So it's keeping that from happening. But just like Nathan said, that's a pedestrian area. You've got a lot of people walking through there on a roadway with cars, and there's a little bit of a bend. So it's definitely a specific area. So
There's some applications where I think it would be beneficial to have something like this.
Yeah.
In certain areas though, I mean, not just everywhere.
Yeah.
Like I said, mainly construction. I feel like, you know, because there's a lot of wrecks right there. I mean, if you have a little fender bender on that and it's backed up all the way to El Paso, you're like, really? You know?
Oh, yeah.
especially since 35 doesn't go to El Paso.
Well, I'm saying, okay, Dallas, it's backed up all the way to Dallas, you know? And then it curves on 20 and goes to El
Dallas to Laredo,
Paso.
we ever stop. Any other questions or comments? We'll move on then.
Thank you very much, Nathan.
You're welcome.
Excuse me, Kathy.
Yes, sir.
I wanted to say that I like what was presented, and I like all the comments. I think there's good points on both sides. Again, I'm Van James Mayfield, and I have great experience in law enforcement as well. And I can tell you that in my experience in the past, the borders of the concrete barriers being put up, I think they do work when it comes to assigning them and like where we put them. Maybe that could use some attention. I do think it's expensive to put it everywhere. But the idea started where like high crash areas, and how can we, make an impact on those numbers? And when they got put out, the numbers went down. It is a proven fact that the concrete barriers do work. But I agree with some of the comments that it would be expensive and it's not realistic to put it all over the place. So where we do put them is the task, you know what I mean? And so I'm actually going to do a little homework to see, just to answer some of those questions, like who's responsible, and is that something that's being done? Because I do know that, you know, TxDOT is involved, and we definitely look at the safety part of it. Our goal is to reduce crashes, you know, and concrete barriers are safe. So I think it's all good information, and I just wanted to lay some of those facts out there as well.
In that case, we thank you and appreciate you coming and enjoy your day.